welcome to this new video in which we're going to optimize a function subject to a constraint. So we have two examples here in which we're going to use Lagrange multipliers method to minimize a function subject to a given constraint. So let's start with the first one. In the first one, we have to minimize the function f of x and y equals x squared plus y squared subject to 3x plus 4y equals 25. Here I will give you the details of the method. So first of all, you have to start by writing the constraint given here as a function g of x and y equals 0. So if it's already done, you don't need to do this step. If it's given like this, you have to move what's on the right side to the left side. So let's write g of x and y equals 3x plus 4y minus 25 equals 0. So you just move the 25 from right to left, okay? The second step is to form or to construct our Lagrange function. So form the Lagrange function, which is the capital F function given by capital F. Here you're going to introduce a new variable lambda. So you have f of x, y, and you introduce a new variable called lambda, which is equal to the objective function x squared plus y squared plus lambda times the constraint g of x and y. So here plus lambda times 3x plus 4y minus 25. So this is the second step. The third step is to find the critical points for this Lagrange function. So critical points. And to find the critical points, you have to solve the partial derivatives equals 0. So to find the critical points, we're going to first compute the partial derivatives with respect to x, y, and lambda for the capital F function. So let's start with x, which is equal to 2x coming from x squared. There is no x in the y squared, so it gives 0. And we have here 3x. Its derivative is 3 multiplied by lambda. So it's 2x plus 3 lambda. We also compute fy, which is equal to 2y, same thing, plus 4 lambda. And the third quantity you have to compute is f lambda. And I give you here a hint. The f lambda is always the constraint g of x and y. So my recommendation is to not expand this term here. So you just write that it's 3x plus 4y minus 25. Now, to find the critical points, you have to set your partial derivatives equal to 0 and solve the system, okay? We have a system of 3 variables, 3 equations. So the best way to solve this system is to express x as a function of lambda, to express y as a function of lambda, and to insert the 2 expressions in the third equation to get an equation with only lambda inside. So let's do this. So let's call 1, 2, and 3. And from 1, we get x equals negative 3 over 2 lambda. From equation number 2, we'll get y equals negative 2 lambda. And we insert these 2 expressions in equation number 3, we'll get 3 times negative 3 over 2, which is negative 9 over 2 lambda, plus 4y. If you substitute the y by negative 2 lambda, you will find minus 8 lambda minus 25 equals 0. Now you are dealing with one equation, one variable. Negative 9 over 2 lambda minus 8 lambda. If you put a common denominator here, you will get negative 25 over 2 lambda, which is equal to 25. By solving this, you will get lambda equals, so here you will get lambda equals negative 2. So we found the value of lambda. You need also to find the value of x and y to write your critical point. So let's compute the x and the y. The x is equal to negative 3 over 2 times lambda. The lambda is -2, so the x is equal to 3, and the y is equal to -2 lambda. The lambda is equal to -2, so the y is 4, and of course the third variable lambda is equal to -2, and this is your unique critical point here. So it will be the point where this function has its minimum subject to this constraint. Okay, so let's write the conclusion for this first question. So we're going to write that the minimum of the function f of x and y equals x squared plus y squared, subject to 3x plus 4y equals 25, is f of x, y, which were found previously. It means f of 3, 4. Okay? Now we're going to move to the second question in this activity. We'll use also the Lagrange multipliers method to minimize the new function f of x and y equals x minus 1 squared plus y squared, subject to y squared minus 4x equals 0. So first of all, you have to write your constraint as an expression equals 0, and it's already done. So you skip the first step. Now you move to the second step, which is the construction of the capital F function. So let's write it, f of x, y, lambda equals x minus 1 squared plus y squared, which is the objective function to minimize, plus lambda times the constraint y squared minus 4x. Again, here to find the critical points, you have to compute the partial derivatives, fx, fy, and f lambda. You solve the partial derivatives equals 0. So let's compute fx first. Fx is given by the derivative of x minus 1 squared with respect to x, which is 2 times x minus 1, using the chain rule for powers. Okay. Now, plus nothing here because it's y squared, and here the derivative of lambda times minus 4x is minus 4 lambda. So it's not plus, it's minus 4 lambda. The second partial derivative fy is equal to 2y plus 2 lambda y, which comes from the y squared times lambda here. So 2 lambda y, okay, equals 0, and the last partial derivative is y squared minus 4x equals 0. To solve this system, I will enumerate these equations 1, 2, and 3. And you can see in the second equation that we have a product lambda y. So it's not easy to get lambda as a function of y or y as a function of lambda, but we can do better. We can put 2y as a factor in the second equation. So let's write it as 2y times 1 plus lambda equals 0. And here we have a product which is equal to 0. So one of the terms here is equal to 0. So the solution here is either 2y equals 0, which makes y equals 0, or lambda plus 1, or 1 plus lambda is equal to 0. It means lambda equals -1. So you have two possible cases to solve the second equation here. So we're going to distinguish these two cases. We'll start with the first case, which is y equals 0. And from the value of y, we'll try to get the values of x and lambda. Okay, we can use the third equation here to get x. So let's use the third equation, and we're going to write that 0 squared, which is 0, minus 4x equals 0, which gives x equals 0. So from y equals 0, we found that x equals 0. From the first equation, which is 2 times x minus 1 minus 4 lambda equals 0. We have already the value of x, so we will get the value of lambda. So let's write it. It's 2 times 0 minus 1 minus 4 lambda equals 0, which means that you have minus 2 minus 4 lambda equals 0, which means that minus 2 minus 4 lambda equals 0, and you get lambda equals -1/2. So you found the x, the y, and the lambda. So you found your first critical point. Okay, so we have a first critical point here. Now we're going to move to the second case in which lambda equals -1. So second case, sorry. Lambda equals -1. And we can use the first equation to get the x from this first equation. So we have 2 times x minus 1. Remember that we have 2 times x minus 1 minus 4 lambda equals 0. The lambda is equal to -1, so we can write +4 equals 0. And here we'll get 2x minus 2 plus 2. It means 2x plus 2 equals 0, which means that x equals -1. So we got the value of x. Now we still need to find the value of y. We'll get the value of y from the third equation. Remember that the third equation is y squared minus 4x equals 0, and we have the x. So let's substitute the x by its value. We have y squared minus 4x equals 0. The x is equal to -1, so it becomes y squared plus 4 equals 0, which means that y squared equals -4, but this is never true. And you conclude that this is not a critical point since you didn't find a value for y. So remember that a critical point is a point which is a solution for your system. So if you find lambda and x but not y, it's not a critical point. So the only critical point in this case is the first one, which is x equals 0, y equals 0, and lambda equals -1/2. And we're going to conclude that the minimum of the function f of x and y equals x minus 1 squared plus y squared, subject to the condition. So let's look to the condition. The condition is y squared minus 4x equals 0, subject to y squared minus 4x equals 0 is f of 0, 0, since the only critical point is x equals 0, y equals 0, and lambda equals -12, but we don't need the lambda. We just put the values of x and y. Okay? We are done with this activity. See you in the next videos.